Section 8.6, we want to factor polynomials of the form ax squared plus bx plus c. So this is a little different than what we did before. Now we're talking about factoring polynomials with a leading coefficient. In the last session, you factored trinomials of the form x squared plus bx plus c. Now you will factor trinomials of the form ax squared plus bx plus c, or a equals 0. And there is a box here telling you how to factor using the AC method. I'm actually going to teach you a different way, and we call this slide divide factoring. So let's start with our first example. So with the slide divide method, the first thing we want to do is take our leading coefficient and we're going to slide it to the back through multiplication. So that becomes, and we want to keep in mind what this coefficient was, so we'll just leave a note out here to ourselves, 6. And so this becomes x squared plus 13x plus 30. We're multiplying. And so now we're going to factor this like the previous section. So the factors of 30 that add up to be 13, well, that's going to be 10 and 3. And so we'll create our two binomials, x plus 10 and then x plus 3. So we've got our two binomials, x plus 10 and x plus 3. Here comes the divide portion. And so now we're going to attempt to divide both of the factors by our leading coefficient. This is where it gets its name, slide divide. And so as we do this, we should see whether or not it divides evenly or if we can reduce the fraction that's there. In both cases, we can reduce both of these fractions. So let's rewrite it with the reduced fraction form. So x plus, well, this becomes 5 over 3. And this one, we've got x plus 1 over 2. In both of these cases, neither one of the values in the denominator go evenly into the numerator. So what we're going to do instead, since we don't want fractions here, is we're going to take the denominator and we're going to slide it back out in front. And so our factored form becomes 3x plus 5. Same thing here, we get 2x plus 1. So this is the factored form of the polynomial 6x squared plus 13x plus 5. If you were to FOIL this back out, you'll get the same answer you started with. Next problem, same idea. We want to slide the leading coefficient to the back through multiplication. So that becomes a squared minus 14a plus 24. Remember, our leading coefficient was a 3, just to keep note of. All right, so factors of 24 that give us negative 14, negative 2, negative 12. So in this case, we've got a minus 2 and a minus 12. In both cases, we want to divide by our leading coefficient, so divide our factors by our leading coefficient. All right, and so right off the bat, we should notice 2 is not divisible by 3, and we can't reduce this fraction, so we slide the 3 back out in front. We get 3a minus 2 is our first binomial. But here, 12 is divisible by 3, so we simplify it, a minus 4. And this is your answer. All right, we're going to move on to the next one. Same idea here. We want to slide this up front. So remember, our coefficient is a 6, so we've got r squared minus 23r plus 120. The factors of 120 that add up to be negative 23, well, that's negative 15 and negative 8. We'll create our two binomials, r minus 15 and r minus 8. In both cases, we want to try to divide by that 6. In both cases, 6 does not go in evenly. So instead of dividing by 6, we're going to try to simplify the fractions first before we move anything. So we've got r minus, well, this becomes 5 over 2. And this becomes r minus 4 over 3. In both cases, the denominators don't go evenly into the numbers above, so we slide the numbers back out in front. And so our factored form becomes 2r minus 5. And here our factored form becomes 3r minus 4. And that is our answer. When we have ax squared plus bx minus c, we do the exact same thing except one of our factors has to be a negative. So keep this in mind. One of the factors has to be a negative. So in this case, we've got 3g squared plus 4g minus 15. We're going to do the same idea. We're going to slide. We've got g squared plus 4g minus 45. The factors of negative 45 that add up to be 4 are going to be 9 and negative 5. So we create our two binomials, g plus 9 and g minus 5. Now we want to try to divide by our leading coefficient, which in this case was 3. In the first binomial, 9 is divisible by 3, so we can write g plus 3 because we simplify it. And then in the second one, 3 does not go into 5, so we bring it out in front. So we get 3g minus 5. In the next example, same idea. We're going to slide, so 6 times negative 4. So we'll get y squared minus 23y. 6 times negative 4 is negative 24. Factors of negative 24 that give us negative 23 are negative 24 and 1. And now we want to create our two binomials. So we're going to have y minus 24 and y plus 1. We want to make sure that we try to divide by our leading coefficient, which in this case is 6. So we divide by 6. In the first binomial, it simplifies. 24 divided by 6 is just 4. So we get y minus 4. In the second one, you can't divide 1 by 6, so we slide the 6 out in front, and we get 6y plus 1. We want to do the same thing here. We've got 2k squared minus 13k minus 24. So we'll slide. So that's k squared minus 13k minus 48. The factors of 48 that add up to be negative 13, it's going to be negative 16 and 3. So we create our two binomials, k minus 16 and k plus 3. We want to try to divide by our leading coefficient, which was 2 in this case. It works here. 16 divided by 2 is 8, so we get k minus 8. It doesn't work in the second one, so we slide the 2 back out in front. So we get 2k plus 3. This is our factored form. Sometimes it becomes necessary to factor out a greatest common factor from a polynomial before you start the factoring process. Not only does it make the number smaller, but it also makes it easier to handle, easier to work with. So let's go ahead and look at the first two examples here. We've got 18x squared minus 33x plus 12. Right off the bat, we should notice that they have a greatest common factor amongst the three terms. The greatest common factor is just 3. So we want to go ahead and factor 3 out to start the problem. So that gives us 3 times the quantity 6x squared minus 11x plus 4. Now we want to use slide divide factoring to factor the interior polynomial. So we'll take 6 and multiply by 4. This gives us x squared minus 11x plus 24. Factors of 24 that give us negative 11, well, that's going to be negative 8 and negative 3. So we create our two binomials, x minus 8 and x minus 3. Now we want to make sure that we try to divide by our leading coefficient. So our leading coefficient was 6, so we're going to try to divide this by 6 and this by 6. Well, in both cases, neither one works, but we can simplify these. So instead of 8 over 6, we can put 4 over 3. Instead of 3 over 6, we can do 1 over 2. And we're going to bring this out in front because it doesn't work. So here we've got 3x minus 4. Then we'll bring the 2 out in front. So we've got 2x minus 1. And we're almost done. The very last step of this is to make sure we bring down the GCF we factored out in the beginning, and we want to tack it on the front of the two binomials. And so this is our completed factored form. We'll do the second question the same way. We're going to see if we can find a GCF first. Well, our greatest common factor amongst these terms is just going to be a 4. And so we're left with, when we factor out the 4, we're left with 2y squared minus 9y minus 5. Now we're going to use slide divide factoring. So we slide. That gives us y squared minus 9y minus 10. Factors of negative 10 that add up to be negative 9, well, it's going to be negative 10 and 1. So we've got y minus 10 and y plus 1. Then we want to divide by our leading coefficient, which in this case was 2. In this case, 10 is divisible by 2, so we've got y minus 5. Here it's not, so we bring the 2 back out in front, and we get 2y plus 1. Your last step is to carry down your GCF. So that's 4. And so your final answer is 4 times y minus 5 times 2y plus 1. Last problem, same idea. Look for your greatest common factor first. In this case, our GCF, once again, is 4. So we're going to factor out a 4 to start off with. We get 3p squared plus 5p minus 2. We want to use the slide divide factoring. So 3 times negative 2 is negative 6. So we end up with p squared plus 5p minus 6. The factors of negative 6 that add up to be a positive 5, positive 6, negative 1. So we've got p plus 6 and p minus 1. We want to try to divide by our leading coefficient, which is a 3. So we try to divide both of these by 3. 6 divided by 3 is just 2, so we've got p plus 2. And then the 3 doesn't divide into the negative 1, so we bring it out in front. We get 3p minus 1, and then we carry down our GCF, so the 4 goes out in front. So our final answer is 4 times the quantity p plus 2 times the quantity 3p minus 1.